Hi! As you may already know, there was a huge volcano eruption in the southern Pacific yesterday, on the 15th of January 2022. The Hunga Tonga Hunga Ha'apai volcano erupted, sending a huge plume into the atmosphere that was picked up easily by multiple satellites. Apart from the plume, it created a shockwave. That shockwave was registered as a spike in atmospheric pressure all over the world, and this is what I want to talk about today. For example, barometers in Warsaw, Poland picked up this spike at roughly 1850 UTC, 14.5 hours after the explosion. Now the interesting thing is that by looking at the times the shockwave was registered in various locations, we can draw some conclusions about the shape of the Earth. This is because the shockwave travels at roughly the same speed in all directions, so all the locations that register the shockwave at similar times must be at similar distances from the volcano. There is a nice website which I will link in the description where you can view data from meteo stations all over the world. Using it, I found about 30 locations scattered everywhere and screenshotted the pressure charts from yesterday, so I can show you how to get them. You just click a meteo station, here by station ID, then you get the data from this station, and you can scroll down to find the pressure chart, and if you switch the date to yesterday, you will see the chart from yesterday, and you can actually clearly see the pressure spike from the shockwave. So I'll show you the data I got from this website now, along with a few charts I found on other websites. So I have data from Ålesund, Norway, Araquari in Brazil, Beja in Tunisia, Chita in Russia, Colorado, this is from a city called Golden, Concon, Chile, I can't pronounce this, in France, Virginia Key in Florida, Granada in Spain, Hong Kong, I can't pronounce this either, in South Africa, Key West in Florida, Kigali in Rwanda, Kololi in Gambia, Kiev, Ukraine, McMurdo Station in Antarctica, Melbourne, Australia, a few cities from New Zealand, Quilmes, Argentina, San Isidore in Canada, San Carlos in California, United States, Sand Island in the Midway Atoll in United States as well, Scott Glacier in Alaska, Szachtersoye in Kazakhstan, Torhop in Norway, Warsaw, Poland, and Zinder in Niger. Now most of this data was expressed in local time, only somewhere in UTC, so we have to convert all the times to UTC so that we can compare them easily. I prepared a spreadsheet for this purpose. I listed the locations, found their coordinates and time zones, and then converted all the times to UTC. I also sorted these by the UTC time of the shockwave arrival, so this list shows the locations sorted by distance from the volcano. The next step was to plot these on a flat Earth map. Of course, there is no single flat Earth map, I wonder why by the way, but the most common one is the AE map. So this is what I used and this is the result. The locations are color-coded. Red represents the locations where the shockwave arrived the earliest, then through orange, yellow, green to blue where it arrived the latest. We can see a few weird things right away. Initially the distances look somewhat right, although Sand Island and Melbourne times are already strange. The shockwave reached Melbourne over an hour earlier than Midway, even though Melbourne looks further from the volcano than Midway. But that's nothing. Let's look at Colorado and Chile. The shockwave reached them at almost the same time, 13 and 1310, even though Chile is a few thousand miles further on this map, so what the heck. And same for Brazil, Argentina, Canada and Russia. Canada and Russia seem to be much closer to the volcano than Brazil and Argentina, and the times are very similar. But the strangest thing of all must be what is happening in Africa. If you look at the points there, it seems as if the shockwave was traveling towards a point in North Africa from all sides simultaneously. We have Kigali in Central Africa at roughly the same time as Europe, then later we have points around Northern Africa and Spain. It would seem like somehow that area is farthest from the volcano on Earth. Interesting, isn't it? So let's look at what this looks like on a globe. To make it easier to see distances, I drew circles every 2250 kilometers from the volcano. This distance corresponds to roughly 2 hours of travel at the speed of sound, so the shockwave should take about 2 hours to travel between subsequent circles. So let's look at what this looks like. The volcano exploded at about 4:20 in the morning UTC time. Then after roughly 2 hours, at 6:15 to 6:40, the shockwave reached New Zealand, and this coincides with the circle that denotes 2 hours of travel, and that's about 2 hours later than the eruption, so everything looks fine. Then we have Melbourne at 8 and Sand Island at 9:20, and we can see that the times now make sense, because Melbourne is slightly inside the second circle, and Sand Island is slightly outside, so it makes sense that the shockwave arrived there later. Next, the shockwave reaches McMurdo in Antarctica, and we can see that the time again corresponds well to the distance. The circle is 6 hours distance, and McMurdo registered the shockwave almost 6 hours after the eruption. Next, we have Hong Kong and California at similar times. Soon after comes Alaska, Colorado, and Chile, which turns out to actually be at similar distance from the volcano as Colorado, which again starts making sense on a globe. Next, again at similar times, we have Florida, Argentina, and on the other side of the world, Russia, which didn't make sense at all on the AE map, but we can see that these places actually are at similar distances from the volcano. Next, we have Canada and Brazil, again at similar distance between this circle and this circle. Then we finally get to South Africa, and here we can see that it's no wonder that it's next. The shockwave reached it by traveling here over Antarctica, which would be impossible on a flat Earth with Antarctica as a ring around the world. At a very similar time, the shockwave reached Kazakhstan, and we can see that these two places lie very close to the same circle, corresponding to 12 hours of travel at sound speed. After that, the shockwave reaches Europe and Central Africa. We have times in Norway, Poland, Ukraine in close succession, and at similar time Kigali in Rwanda. The last place in Europe to be reached is Spain, and roughly at that time the wave reaches also Gambia and Tunisia. Then shortly after, Zinder in Niger. On the globe this is no surprise, these are indeed the points that are almost the furthest away from the volcano. I would gladly include some data from southern Algeria here, as this is where the center of the last circle is, so that we could see that the wave reached there even later. But unfortunately this is deep Sahara desert, and there don't seem to be any stations available online there. So what does the eruption tell us? We can clearly see that the distances on the globe fit the times of shockwave arrival perfectly. And not surprisingly, they make no sense on a flat map. And that's not just the problem of this particular flat map. There can be no flat map where these times match the distances. No flat map can have a single point that is the furthest from another point, also known as antipodes. And here we can see that we have something like that. Clearly the travel times are increasing as we get closer to southern Algeria from all sides. You could look at more stations and this will only get more obvious. Flat Earth doesn't work, and you can see it in this data for yourself. And that's all I have for today. Thanks for watching and see you in the next one. Bye!